Hi everyone, let's start a new topic of indices, which is simplification. These questions can be of three types, either simplification or finding the value, or solving and finding the value of the missing variable. For example, the typical question you see over here is a simplification question. It's given x cube y square multiplication divided by xy whole square. It's not xy square, it's pronounced xy whole square. When we say xy square, it's x and then just followed by y square. So be very careful when you're reading it or studying this. This is once again not xy square but xy whole square. Let's start the process of simplification. So we can write it as x cube y square divided by xy whole square. The further xy whole square can be written as x cube y square, and remember this can be written as x square followed by y square. We are just expanding it. Now observe the x terms, they are like terms, cube and square. We can write it as x to the power 3 minus 2 because it's a division, and we have y square and y square, which is again in the form of division, so we can write it as y to the power 2 minus 2. Followed again, 3 minus 2 is going to give you 1, that is x to the power 1, and 2 minus 2 is of course going to be 0, so y to the power 0. Remember, for real numbers, any real number raised to the power 0 is 1, and x to the power 1 is of course going to be x, so the answer is x. That is your answer. So this expression just evaluates to x. Let's go for the second question, which is solving and finding out the value of the missing variable, in this case x. So you have 3 into 27 to the power x equals 9 to the power x plus 4. You can notice that 3, 27, 9, all of them are multiples of 3. 3 into 1 is 3, 3 into 2 is 9, 3 into 3 is 27. So we can write it as 3 power 1 implies 27 can be written as 3 cube followed by x. Remember to put brackets over here so that we don't do any mistakes if the expression is too large. And 9 can be written as 3 square followed by x plus 4. At this point I prefer to write x plus 4 as brackets because it's one single expression. Often the mistake which we do is when we are expanding this, we write it as 2x plus 4, which is wrong because 2 needs to be multiplied with the entire thing. Let's now go ahead. So this can be written as 3 power 1, 3 and x, and the powers will be multiplied making it 3x, and over here it's going to be 3 to x plus 1, that is you're multiplying 2 with x and 4 both. Coming back, now we can write, because it's the base is same and the powers are different, we make it 3x plus 1. Remember, addition is commutative, so whether we write it as 1 plus 3x or 3x plus 1, it's the same thing. Remember, writing 1 plus 2 or 2 plus 1 is exactly the same thing because addition is commutative. Now this is going to be equal to what? 3 power 2x plus 8. Now whenever you get a situation like this, mind it, there needs to be one term over here and another term over here. It can't be 3 to the power x plus 3 to the power y or something similar. It has to be just one term over here and another term over here, both raised to the same base. We can mention that because the base is same, the powers must also be similar or equal. Since the bases are, you can take a note of this, since the bases are same, the powers have to be equal, which implies 3x plus 1 would be equal to 2x plus 8. Now we simply have to solve it. We can make it as 3x minus 2x followed by 8 minus 1. We are doing a simple substitution where we are shifting 2x over here and 1 over here, because it's a plus. When it goes over to the other side it would become a minus, and when 2x is positive, because it's moving to the other side, it would become negative. Or we can simply mention this as Evaluating 3x minus 2x is x and 8 minus 1 is 7. Therefore, your answer is x equal to 7. This is our missing value.